Okay, so in the last class, what I have explained? So explained about the radar. Okay, so it is what do you mean by the radar? It is what is the basic principle of the radar, and what is the block diagram, and what are the applications of the radar. Okay, so if you take the expansion of the radar, it's nothing but it's it is it is the radio detection and ranging. Okay, no. uh, so if you take the basic working principle, so that if any of the signal is to be passed into the space, it is to be get reflected by the target, and it is based on the target signal, or it is based on the reflected signal. It can able to measure its position and its range and its direction. Okay, no, this is the basic principle of the radar. Okay, and if you take the block diagram of the radar, so that it is mainly consisting of what? It is mainly consisting of the transmitter, it is to be followed by the duplexer, and it is to be followed by the radar antenna, and it is consisting of the receiver and the indicator. Okay, so that it is what the transmitter it will do, it is going to radiate the what RF signal, and it is to be passed into the duplexer, and what that duplexer it will do, it is going to give the connection, it is for the transmitter, and after that it is to be passed for it is a radar antenna, and what it will do, it is going to convert that RF signal into what EM signal, electromagnetic, and afterwards it is to be radiated into the air, and afterwards it is to be get hit by the target, and out of that it is going to get, it is part of the signal again back to the radar antenna, and it is acting as of the received signal, and again it is to be passed into the duplexer. In this case it is going to give the connection, it is for the receiver, and it is going to demodulate that signal, and after that it is to be passed into the indicator. It's nothing but the display. Okay, this is all about the block diagram of the radar, and in this class we are going to see the radar parameters here. It is what are the parameters of the radar, so all that it is going to be studied in this class here. Okay, so that if you take the parameters of the radar, so okay, if you take the range, if you take the range, or if you take the maximum what unambiguous range, if you take the PRF, it's nothing but it is pulse repetition frequency, it is PRT, it is the pulse repetition period, okay, or the time. If you take the duty cycle, or if you take the peak power, if you take the average power, all these are the parameters of the radar here. Okay, so all that we are going to study in this class here. So initially, if you take the range, so it is what is the range? So the range of the target is observed by measuring the time indicated as the TR, and it takes for the radar signal to travel to the target, and it is going to return back again to the radar itself, is going to give you the range here. Okay, so that if the signal is going to be emitted is from the antenna, after that it is going to hit, it is for the target, and after hitting again it is going to be reflected, and it is going to be come back again for the radar antenna. So how much amount of the time it is going to take in order to reach, it is for the target and again to come back. So it is based on that it can able to measure the range here. Okay, so how much amount of the time it is going to take in order to travel from the antenna, it is to the target, and afterwards to come back again for the antenna. It is based on that it can able to measure the range here. And what this range of the target is to be given by, it is TR is equal to, it is 2R divided by C. In this case, what this TR, it is the interval time. Okay, and what this two, it is nothing but the multiplication constant. R is the range, and what this the C is again the constant. Okay, it is to be represented as of the TR is equal to, it is 2R divided by C, and it is to be measured in terms of the kilometers or in terms of the nauticals. And what is a t? It is to be measured in terms of the microsecond. It is equal to 10 to the power of minus 6. It is within the fraction of second. It can able to go, it can able to identify the target, and again it is going to come back. Okay, this is about the range here. And in this case, what do we mean by the unambiguous range? Okay, if the time between the pulses TP is too short, an echo signal is from the long range target, it might arrive after the transmission of the next pulse. Observe here, afterwards you can write down. Okay, and it is what the echo arrives after the transmission of the next pulse is called as the second time around echo, or it is also called as of the multiple time around echo. And what it is the range beyond which the target appears as the second time around echoes is the maximum unambiguous range. It is indicated as RUN. Okay, R, and what this UN is the subscript here. Okay, what this indication of the UN is an unambiguous, R indicating the range here, and it is to be given by the formula R UN is equal to CTP divided by 2, and again what this C is the constant value, and what this T is an interval time period. Okay, and already you know that what this T is equal to 1 divided by F, and if it is to be placed in this equation, so that you can able to get it is C is equal it is R UN is equal to C divided by 2 TP. Okay, so in this case, what this maximum unambiguous range means, it is going to allocate the interval period. So if the signal is to be transmitted, it can able to receive the echo signal, it is within the allotted time. If it comes within the allotted times, means it is going to be accepted as it is. And if it comes after the allotted time, means it is called as the second time around echo. Okay, after transmitting the second pulse, it can able to receive the reflection of the first pulse. Understanding? After transmitting the second pulse, it can able to receive the echo of the first pulse. If it occurs in this way, it is itself is called as the unambiguous range, and it is to be given by the formula R UN is equal to it is CTP divided by 2, or it is also to be given by it is C divided by 2 into FP. What this TP is the pulse repetition time, and what this FP is, it is pulse repetition frequency. It can be understood with the diagram also. See here, it is the transmitted signal here. Okay, and it is the first transmitted signal here, and you can able to see this is the second transmitted signal, and it can able to receive the echo, so that you can able to see this is the echo pulse here. And if it can be able to be received, it is within the receiving time. Okay, it is assumed as of the very good echo, and it can be accepted as it is. If the first echo occurs, after transmitting the second pulse, if you assume this as of the echo of the first signal, means it is called as an unambiguous range. So it has been crossed its time limits. So it is assumed to be as the original first signal has been lost, and it is also to be neglected there. So this is the receiving time. It can able to receive the reflected signal. It is within the allotted time. If it can able to receive, it is within the allotted time, means it is what is that maximum time itself is called as an unambiguous range. Understood? Okay. So if it can able to receive the signal, it is called as only the range. And if it can able to receive, it is within the maximum allotted time, it is called as an unambiguous range. Understood the difference? Okay. And if you take the pulse repetition frequency, it is the rate at which the pulses are to be transmitted towards the target is from the radar is called as this pulse repetition frequency. It's nothing but the rate at which it is to be transmitted. It's nothing but its a frequency. It is to be measured in terms of the megahertz or in terms of the gigahertz here. Okay, and if you take as of the pulse repetition period or the interval, it is PRI or it is PRP. Okay, it's nothing but what this TP is equal to, it is 1 divided by TP. It is an interval time at which the pulses are periodically, it is to be transmitted towards the target from the radar. It's called as, it is pulse repetition period, it is TP. Understood? It is the rate at which the pulses are to be transmitted. It is to be measured in terms of the what hertz, and it is the interval time, okay, at which the pulses are periodically transmitted. It is to be measured in terms of the time. If it is to be measured in terms of the what hertz, it is called as of the pulse repetition, what it is a frequency. And if it is to be measured in the interval of the time, it is called as of the pulse repetition spirit. Understood? Okay. So it is itself is to be, it is represented, you can able to see. So if, so that you can able to see the pulse here, it is the first pulse and it is the second pulse here. And if you take the interval between, it is first, it is pulse and it is the second pulse, it is itself is able to give you, it is pulse repetition time, interval time, how much amount of the time it can able to take under the, it is waiting for the echo in order to transmit the second signal. Okay, and in the same way, if you take the reference as the second pulse, means how much amount of the time it is going to wait in order to reach or in order to receive the echo of the second signal earlier to the transmission of the third pulse. Okay, it is going to indicate as of, it is pulse repetition time or the interval, it is itself. If you take the frequency, means so it is going to indicate the number of the pulses there, it's a rate. Okay, if you take the duty cycle, it's nothing but it is the radar waveform is described as the ratio of the total time the radar is radiating to the total time it could have, okay, radiated. So it's actual allotted time and it received time. If you take the ratio of that one, it is going to give you the actual duty cycle, so that you can able to understand with the graph itself here. So from at this point to at this point is the what allotted time. So but it can able to receive the echo in the early time. So how, so if you measure the time from at this point to what at this is the radiated time, and if you measure from at this point to at this point, it is the actual allotted time. Okay, if you take the ratio of that one, it is going to give you the actual duty cycle. Okay, if you want, means you can read the sentence one more time. If you take the duty cycle of the radar waveform is described as the ratio of the total time, the entire allotted time, it is to the radar, it is total time it could have radiated. Okay, the actual allotted time and how much actually it has taken in order to complete its operation. Okay, if you take the ratio, it is to be indicated as of the PAV divided by PT, or it is to be indicated as of the tau divided by TP, or it is equal to tau into FV. It is going to give you the duty cycle here. Yeah, and again that what this T is the pulse width of the transmitted pulse. TP is, it is pulse repetition period here. Understood? Okay. Is there any doubt? Okay. And if you take the peak power of the radar and the average power of the radar, what this peak power, it is to be considered only in the single direction. And if you take the average power, it is to be considered in all direction in the isotropic. So if you take the maximum power of the radar antenna, it can be transmitted for the maximum unambiguous range, okay, in which detection is in the particular, okay, direction. If the antenna is going to transmit or is going to concentrate the signal under the particular direction, Okay, it is what its maximum power is to be measured under the particular direction is going to indicate as what the peak power. And if the antenna, again the same sentence you can able to see, if the average power of the radar antenna, okay, that can be transmitted for the maximum unambiguous range target attack, it is a detection in all the direction. Okay, it is for the isotropic antenna this is. And if it can able to radiate the signal in all the direction, and if you take the average power of all the direction, it is going to indicate the average power. Okay, this is all about the parameters of this okay radar here. Okay, what's the range? So how much amount of the time it can able to take in order to receive the echo signal, and what this maximum unambiguous range if it is going to receive the echo signal after the transmission of the second pulse. And if you take the pulse repetition frequency, it's nothing but the rate, it is to be measured in terms of the hertz. If you take the pulse repetition period, it's nothing but the interval of the time of the pulses. If you take the duty cycle, so how much amount of the actual allotted time and how much amount of the time actually it took. If you take the ratio, it is going to give you the duty cycle. And if you take the power under the single direction, it is called as the peak power. And if you measure the power along all the directions, it is going to give you the average power. Understood? If you take the possible okay question means, so he may ask you to list and explain the parameters of the radar. Okay, so it is all about the parameters, and in the next class we are going to see the radar range equation. Okay, okay, thank you very much.